All right, now we are going to start on chapter 7, which is all about probability and living with the odds, is the subtitle. But this is basically an introduction to probability. And the first section in chapter 7 is just on some probability fundamentals. So first, we're going to have a couple of definitions. Whenever you're thinking about probability, the idea is always that there is an underlying probability experiment or observation going on. It could be something as simple as flipping a coin or rolling a die. Maybe you're making observations from a group of people. So, I could look at, if this were a face-to-face class, I would look at all the students in the room and observe how many of them wear glasses and calculate the probability from that. But that's always the underlying idea. And an outcome is the most basic possible result from an observation or an experiment. For example, if you toss two coins in the air, okay, if you toss two coins in the air, think about what can happen. If you toss two coins together, say a quarter and a dime, then you could have both of them come up heads. You could have one of them come up heads and the other one tails. You could have the first one come up tails and the second one heads, or both of them could come up tails. So these are all of the possible outcomes when you flip two coins. An event, which is what we calculate probability of, an event consists of one or more outcomes that share a property of interest. For example, if you toss two coins and you count the number of heads, then the outcomes heads tails and tails heads both represent the same event. Okay, so in this example here, we're not thinking about the outcomes when you flip two coins. We're thinking about the event of getting one heads. And so HT and TH both represent the same event if we're counting the number of heads, because both of those have heads. Have one heads and one tails. And here's our first example. So consider a family that has two children. What we want to do is list all of the possible outcomes, first of all, for the birth order of boys and girls. And then if we're only interested in the total number of boys in the family, what are the possible events? So first of all, I'm going to list out all of the possible outcomes for the birth order. So the family has two kids. So one possibility, just going alphabetically, would be going alphabetically, the first possibility would be BB. So let me change that to BB. Now, the next possibility would be BG. So what this means when I write it like this, because this is respect to birth order. This means they have a boy first and a boy second. This means they have a boy first and a girl second. Another possibility would be having a girl first and a boy second. And the last possibility would be having two girls. Okay, so this is all the possible outcomes for a family that has two children. Now, the second part of the problem says, if we're only interested in the total number of boys in the family, what are the possible events? So the events, if all we care about are the number of boys, well, they could have two boys, they could have one boy, or they could have 0 boys, and those are the possible events. So think about how many ways this can happen. The event of having 2 boys, that can only happen one way. That can only happen if the family is boy-boy. But the possibility of having one boy, that can happen 2 different ways. If they have a boy first and a girl second, or a girl first and a boy second. The event of having 0 boys, that can only happen one way, and that is the event of having 2 girls. So that last example hopefully has you thinking a little bit about the probability of the events, because we're starting to count how many ways these events can happen. Before we get into some formal definitions of probability, a few things that are important that I want you to keep in mind. We calculate probability of events, okay? And we write it like this: P parenthesis event, close parenthesis. And this is read just like a function, P of an event. Now, this um, probability is a number, and it's always a number between 0 and 1 inclusive. That is, we have this very important equation that for any event A, the probability of A is always greater than or equal to 0, and it's always less than or equal to 1. And as you know, a probability of 0 means the event is impossible. Probability of 1 means the event is certain. And we typically think of probability as occurring on a continuum like this. 0 probability is something that's impossible. And between 0 and 0.5, that's an unlikely event. Okay, something that's probability 0.5 is a 50-50 chance, and we mean that a little bit colloquially. You know, we've not talked about what chance or odds means yet, but just your intuition, 50-50 chance. Something between 0.5 and 1 probability is more likely to occur than not, and in something of probability of 1, then it is certain to occur. Now, we're going to look at 3 different types of probability. The first one is called the theoretical method for equally likely events. Now, I want to underline uh, this phrase right here: equally likely outcomes. I think I may have said events a second ago. For equally likely outcomes, you can only use this theoretical method if you really do have equally likely outcomes, where every outcome has the same chance of occurring as every other one. And this is generally what we think of when we just say probability. So, step one, you count the total number of possible outcomes. Step two, among all the possible outcomes, count the number of ways the event of interest A can occur, and then calculate probability with this formula right here. So, the probability of A is the number of ways A can happen divided by the total number of outcomes. So notice that we are counting and then doing division, and that's how theoretical probability works. So let's look at our first example of theoretical probability. We're going to do one with coins and one with dice. So let's find the probability of getting exactly one head when you toss 2 coins. Well, look, we have a little diagram that shows what can happen. One possibility when you flip 2 coins is you get tails, tails. You could get tails, heads, heads, tails, and heads, heads. And here are the events: 0 heads, 1 head, 1 head, 2 heads. So if I want to find the probability of getting exactly 1 head when you toss 2 coins, well, there are 2 ways that can happen. It can happen by getting tails, heads, or by heads, tails. So there are 2 ways the event can happen, and then we divide by the total number of outcomes. 1, 2, 3, 4. There are 4 outcomes. So by the theoretical probability formula, the probability of getting exactly 1 head is 2/4, which will reduce to 1/2. And then an even more straightforward problem: what's the probability of getting a 3 when you roll a 6-sided die? Well, there is exactly one way to get a 3, and there are 1, 2, 3, 4, 5, 6 outcomes. So the probability of getting a 3 is just 1/6. And that's how the theoretical method of finding probability works. You check to make sure you have equally likely outcomes, and then you count. Count the number of ways your event can happen, then count the total number of outcomes. Okay, for this next example, we need to talk a little bit about playing cards starting out. So there are 52 playing cards in a standard deck. So if you buy a deck of cards, open them up, throw away the jokers, throw away the advertisement cards, you'll have 52 cards left. Now, each card is going to have a suit, and each card is going to have a rank. Now, the ranks are numbered ace, 2, 3, and it goes up like that until you get to 10. And then we have the jack, the queen, and the king. So every card that you take out of the deck will have one of those ranks. Ace, 2, 3, 4, 5 through 10, and then jack, queen, and king. And ace is usually written in A, jack with a J, Q, queen with a Q, and king with a K. All right, now there are 4 different suits. There are 2 black suits, the spades and the clubs, and there are 2 red suits, the hearts and the diamonds. Okay, so what I'm saying is since there are ace through king, there are 13 ranks times 4 suits gives you 52 cards. So there's the ace of spades, 2 of spades, 3 of spades, so on. So there are going to be 13 total spades, 13 clubs, 13 hearts, 13 diamonds, which also means there are going to be 26 black cards and 26 red cards. Okay, now the problem is, if you draw one card at random from a standard deck, what is the probability that it is a spade? Well, the probability that you're going to get a spade, the probability that you'll get a spade, this is going to be the number of ways that your event can happen divided by the number of possibilities. Well, there are 13 spades, so there's 13 ways that you can draw a spade. You'll either get the ace, 2, 3, all the way up through king. You'll get one of those spades, so 13 ways, and there are 52 total possibilities. So the probability you'll get a spade is 13 over 52, which reduces to 1/4. All right, one more example before we move on to the next type of probability. Okay, this is not true. Okay, it is not true that when a woman has a baby, there's an equal chance of having a boy or a girl at birth. But for the sake of simplification and for the sake of doing this problem, we're going to assume that a woman has an equal chance of having a boy or a girl at birth. So, assuming that, what is the probability of having 2 girls and 2 boys in a family of 4 children? So, notice that we have all of the different outcomes listed out. The family could have girl, 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 which the event would be 4 girls. The family could have boy, 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 where the event would be all boys. And then we could have 3 girls and 1 boy in these ways, 2 girls and 2 boys these ways, 1 girl and 3 boys like this. There you go. So we want to find the probability of having 2 girls and 2 boys in a family of 4 children. So first of all, how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 outcomes. Now, out of those outcomes, how many ways are there to have 2 boys and 2 girls, which is what we care about? Well, there are 1, 2, 3, 4, 5, 6 ways. So there are 6 outcomes that are 2 girls and 2 boys. So that tells us the probability of having 2 girls is 6, because that's how many outcomes there are in the event, divided by 16, the total number of outcomes, which is 0.357. So now we come to the second way to calculate probability. And this is called relative frequency probability. Okay? And this is an approximation, and it involves making observations. So this is the difference between the theoretical probability and relative frequency probabilities. In relative frequency probability, you make observations and you count how many times your event A actually happens. Okay? It's called the relative frequency method or empirical method. That is, the probability of an event A is the number of times A occurred divided by the total number of observations. So let's see an example. So in this situation, suppose we're going to flip two coins and we're only interested in the number of heads, okay? So as we've said before, that means the possible events are 0 heads, 1 head, and 2 heads. So now suppose you repeat the two coin toss experiment 100 times. That is, you're going to take a quarter and a dime, flip them together 100 times, and keep track of how many heads you get every time. And when you do that, these are your results. You get 0 heads 22 times, you get 1 head 51 times, and you get 2 heads 27 times. What we want to do in this problem is compare the relative frequency and the theoretical probabilities, and then talk about whether or not we think that the coins are fair or not. So what I'd like to do is go ahead and make a little bit of room over here on the right. So I'm going to make a table. And what I'm going to do is I'm going to have a table where I'm going to have the probability of getting 0 heads and the probability of getting 1 head, the probability of getting 2 heads. And I'm going to calculate those probabilities both ways. I'm going to calculate them using the theoretical method, and I'm going to calculate, actually, the theoretical method, and I'm going to calculate them using the relative frequency method. Okay, so here are the outcomes if I'm using the theoretical method. My outcomes are heads, 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 tails, tails, heads, tails, tails. And then if I'm using when I use the relative frequency method, I have this information over here that I got. Actually, I think there's a better way to maybe do that. Let me erase this line. This is more tricky than I thought it would be because I can't see what I'm doing. If maybe you hear my neighbor mowing. If you do, I apologize for that. But I've been recording this video, and the whole time I've been doing it, I've been thinking, I hope they don't hear my neighbor mowing over there. But if you do, I'm sorry. All right, finally done with that. So what I'm going to do is I'm just going to take this info and just bring it over here. Shrink it down just a touch, and so there we go. So we have everything we need over here to calculate the theoretical probability. We'll use the outcomes, and the relative frequency method will use what happens when we made these observations. Let's do the theoretical method first. Probability of getting 0 heads. So that can happen, and I just noticed I made a typo, and if we were in class, someone would have corrected me, and I would have said thank you by now. So tails, tails. Right. So the probability of getting 0 heads, well, that happened one way out of 4 different possibilities. So the probability is 1 over 4, which is the same as 0.25. The probability of getting exactly 1 head, well, that can happen 2 different ways, heads, tails, tails, heads, out of 4 different ways. So 2 over 4, that's equal to 0.5. And getting 2 heads, that can happen one way, heads, heads. So this is 1 over 4, which is 0.25. So those are all of my theoretical probabilities. Okay? Now, for the relative frequency method, what we have is If you want to calculate the probability of getting 0 heads, well, we have to look at the observations. So we would observe that 0 heads occurred 22 times out of 100 observations. So the probability is going to be 22 over 100, which as a fraction, that is 0.22. And then 1 head occurred 51 times out of 100, so the probability is 0.51. And getting 2 heads occurred 27 times out of 100 observations, so that is 0.27. And so now we have the theoretical probabilities, probabilities by the theoretical method and probabilities by the relative frequency method. And so answering this last question, do you have reason to think the coins are unfair? No, I don't. Because notice that 0.25 is very close to 0.22. 0.5 is close to 0.51, 0.25 is close to 0.27. So because the relative frequencies are close to the theoretical probabilities, the coins are most likely fair. And so now I can tell you about the third approach to probability, and it is subjective probability. And that's basically an educated guess. This is probability that is an estimate that's based on experience or intuition. So our three different types are theoretical probability, based on the assumption that all outcomes are equally likely, and we divide the number of ways an event can happen by the number of possible outcomes. Relative frequency probability, this is based on observations or experiments, and it is the relative frequency of the event of interest. That is, you count the number of ways your event was observed and divide by the total number of observations. And last, like I said, is subjective probability based on experience or intuition. So suppose I said to you, or not me, but you go to shop for a car and somebody slaps top of it and said this car can hold so much probability. That's a meme that I hope you get and isn't too dated if you're listening to this after I recorded it. Suppose you say, I'm 100% certain that you'll be happy with this car. Well, what type of probability is being used there? This is going to be subjective probability. That salesperson doesn't, they haven't done any calculations. They haven't made any observations. They're just making a guess that you'll be happy with the car. Next, based on government data, the chance of dying in an automobile accident during a 1-year period is about 1 in 8,000. Now, this isn't something that someone can reason out and count out all the possibilities and count out how many ways the event can occur. No, this is based on observations. They see how many automobile accidents there are, how many fatalities there are, how many people are driving, and they do this probability calculation. So this is based on relative frequency. And this last example says, suppose that you're told that the probability of rolling a 7 with a 12-sided die is 1 over 12. Now, I found this picture of a 12-sided die, and it is a total coincidence that 7 is what came up. But this is what a 12-sided die looks like. So, well, how many different outcomes are there? There are 12 because there's 12 sides in this die. How many ways can you get a 7? One way it shows up, so the probability is 1/12. Well, how was that calculated? It was calculated by counting the outcomes and counting the number of ways your event can happen. In other words, this used theoretical probability. So that is the end of part 1 of 7a. There's a lot of material in here, so I'm breaking this up into 2 different videos. And so then part 2 will cover probability of an event not happening and probability distributions and a little bit about odds.